All right, here's number 7, another example. So we're given that Q is the midpoint of PR, of segment PR. So find length PQ, length QR, and length PR, right? So we know that Q is the midpoint, so therefore PQ is equal to QR, right? So those are equal to each other. So we're given two algebraic expressions that represent the length of each of those. So we can just set those equal to each other, and then we can solve, right? So I'm going to consolidate my x's on the left. I'm going to consolidate my numbers on the right. So subtracting 5x from both sides, we'll get my x's on the left and ensure that they're both positive. Adding 7 to both sides will cancel out the 7 on the left, get my numbers on the right. So we'll have 6x minus 5x is 1x. 1 plus 7 is 8. So x equals 8, right? And here's the part where, make sure you reread the directions and make sure that you've answered all the questions. Right here, they're not asking for the value of x. They're asking for PQ, QR, and PR, right? So PQ is 6x minus 7, right? So PQ equals 6 times x minus 7. So plug in 8 for x there. So we get 48 minus 7, which is 41, right? So PQ, length PQ equals 41. All right, so now QR, we could plug in x and do 5 times 8 plus 1, right? That would be a good way to check our work, but we already know what it should equal, right? We know that these are congruent, so we know that PQ should equal QR, right? So you could also just put QR equals PQ equals 41, or you could put QR equals 41, either way, okay? And then PR, by the segment addition postulate, we know that PQ plus QR equals PR, right? So if we add these together, then we would get PR. So that'd be 82. The other thing we could do is we could double 41, right? And that would give us 82. All right. So the next one, name each of the following. So number 8, the point DA on, the point on ray DA, right? That's the ray symbol. That is 2 units from D. Okay, so ray DA, so that's going to go towards A, right? So that's ray DA. Starts at D and goes towards A forever, and past A in that direction. And so 2 units from D on that ray would be B, right? B is 2 units away from D on the ray, right? F is also 2 units away from D, but it's not on the ray, and so F doesn't work as an answer, okay? So our answer here would be B, point B. Okay, so number 9, 2 points that are 3 units from D. So 3 units from D, and to the right would be G, and to the left would be A. So points G and A. Okay. All right, the coordinate of the midpoint of AG. So so AG, we have them circled there. So the midpoint, since it's -3 to 3, intuitively we know the midpoint would be 0, right? That would be the coordinate of the midpoint, but we can also do our midpoint formula, 3 plus -3 divided by 2, which would just be 0 divided by 2, which is 0, or we could find the length, which would be 6, 3 minus -3, and then take half of that, which would be 3, and go 3 from either midpoint towards the other, and we'd get 0 as well, okay? All right, number 11, segment congruent to AC, to segment AC. So segment AC is 2 units, right? So we can see that visually, or -1 minus -3 would be 2 as well. So we want something that's congruent to AC. So so any segment that's 2 units would be congruent, right? So we could do DF, we could do EG, there's a lot of different possibilities there. So I'll just say DF. So segment DF. right, and just to make the full statement is congruent to segment AC. All right, and then number 12, name two segment bisectors of PR. So PR is 2 units long, so anything that cuts it in half into 1 unit on each side would be a bisector, right? So Q is a bisector, point Q, but also line L is a bisector, right? All right, does anybody see anything else? I don't, yeah. So those two things are segment bisectors. So number 20, on a number line, the coordinates of x, y, z, and w are -7, -3, 1, and 5 respectively. Find the length of the two segments here below. Tell whether they are congruent. So one thing you do is draw a picture, or just, kind of make sure you associate each coordinate with each point. So I'm going to draw a picture. Ding, so here's my picture. All right, so yz, to find the length of that, I can subtract 1 minus -3. All right, so that gives me 4, right? And to find xw, we could do 5 minus -7. And that gives us 12, right? So those are the lengths. Are they congruent? No, they're not congruent, right? So we can write the congruent symbol with a line through it like that. Okay. All right, number 21. This one's interesting. Suppose the coordinate of A is 0. The length AR equals 5, and length AT equals 7. What are the possible coordinates of the midpoint of the given segments? So this one's a little tricky. A lot of times when people see AR is less than AT, a lot of times people will say, okay, well, on a number line, let me just put arrows here. This could be A, this would be R, and this would be T, right? So people are like, oh, this is 5, and this whole thing here, let me do it this way. This whole thing here is 7, right? So this is 5, the whole thing's 7. So RT must be 2, right? And the coordinate of A is 0, right? So this coordinate is 0. So that might be, that's what some people might use to, or that's the logic some people might use. And that's, so one possibility, if we did use that logic, then the midpoint would be right in between here, right? So that'd be 1 unit. So we'd go 5 units from 0, right? And then another unit. So the one possible coordinate would be 6, right? But think about another way we could write A, R, and T. So it doesn't ever say anywhere that R is between A and T, right? So we could also have A here still at 0, right? We could have T over here, right? And this length would be 7 still, but maybe R is on the other side of 0, right? Maybe R is to the left of A, okay? And this distance would be 5. So if that's the case, then the midpoint here would be 2.5 away from 0, right? So it'd be negative 2.5, right? So you could do, this would be -5 here. So you could do -5 plus 0 divided by 2, or the various different ways, but the midpoint would be -2.5, okay? So those would be the two possible coordinates of the midpoint. So you have to consider, if they don't say that R is in between, then yeah, just remember that R could be in between. That could happen. And that's kind of what people a lot of times just think or assume. But R could also be on the other side of A. Now, it couldn't be over here on the other side of T, right? Because we know AR is less than AT, but it could be on either side of A.